Hello, hi, and assalamualaikum. My name is Muhammad Fahmi Nakib bin Nashrun, and my matrix number is 17206775, and I will talk about friction. So before that, we will start with looking at this friction video, which is have 25 grams of weight on a smooth plane. Okay, so this is the image from the previous video. So from this we will look at the free body diagram of of the weight of 25 gram on an inclined smooth plane. Okay, this is the free body diagram of the previous image. So first we have for normal forces upwards, and we have the weight forces downward. And from the weight forces, we have two components, which is x and y component. For y component, we have w cos theta, and for x component, we have w sine theta. And we have also the static friction force acting at towards the object, which is Fm. So from this, we can get the calculations. Okay, so for calculations, we will make the summation force of x and y equal to 0. But before that, we have the mass of the object with multiple with the gravity, which is W equal to 0.2453 Newton. And as I said, we will have make the summation force of x and y. So for x direction, we have the W sine theta and also the static friction force Fm. And this is the calculation. And for summation of y direction, we have W cos theta from the W, and also the normal force. And we have Fm and Fn, normal force, and so the static friction force. So we can calculate the mu and mu k and mu s, which is the coefficient of static friction force and coefficient of kinetic friction force. And from mu k, we can calculate the Fk, which is the kinetic friction force. And from this, as P increases, the static friction force F increases as well until it reaches maximum value Fm. And further increase in P causes the block to begin to move as F drops to a smaller kinetic friction force, which is Fk, or we call that as kinetic frictional force.